Lab 25, example 1. We want to consider the polynomial function f of x is equal to 20x to the fifth minus 8x to the fourth minus 83x to the third plus 17x squared plus 69x plus 21. This is a problem with parts A through E. For part A, we want to apply Descartes' rule of signs to determine the number of positive and negative real zeros. So, we're going to do the positive real zeros first. So positive real. We're going to look at the signs of all of the coefficients in our polynomial function. The first is a positive 20, so the first sign is positive. The second one is a negative 8, so the second sign is negative. This one is negative 83, so it's negative. Positive 17 is positive. Positive 69 is positive, and then positive 21 is positive. And what Descartes' rule of signs says is that the number of positive real zeros of f either equals the number of variations in the sign of the non-zero coefficients of f(x), or else equals that number less, and that by an even integer. So we're going to count the changes of sign. So here's one change of sign. We have a change from positive to negative. Here's another change of sign from negative to positive. And so we have two changes, and what that means is that we have either two real zeros or we have 2 minus an even integer. So 2 minus 2, for example, would be 0. So we either have 2 or 0 real positive zeros. So that's the first part. We're going to look at negative real zeros. So for negative real, what we're going to do is we're going to plug in a negative x into our function here. So f of negative x is going to be equal to 20 times negative x to the fifth minus 8 times negative x to the fourth minus 83 negative x to the third plus 17 negative x squared, and I'm going to add over here, plus 69 times negative x plus 21. So then we're going to simplify this a little bit. This is going to be equal to, so if we have negative x to the fifth, this is odd, so that means that our negative is going to still be there. So this is going to be negative 20x to the fifth. And we have negative x to the fourth. Negative 1 times negative 1 times negative 1 times negative 1 is going to give us positive 1. If we multiply a negative number an even amount of times, it's going to be even. So this negative here is going to go away. We're going to be left with negative 8 x to the fourth. We have negative x to the third. It's odd, so this is going to be negative. Negative times negative is going to give us a positive, so this is going to give us a positive 83 x to the third. And then negative x squared is going to give us a positive. Positive and positive is just positive, so this is positive x squared. We have negative x to just the power of 1. There's nothing there, so the power of 1 is just going to stay there. And then negative is going to go to the front here. So this is going to be negative 69x and then plus 21. So now we're going to look at the signs of f of negative x. We have a negative 20x to the fifth, we have a negative 8x to the fourth, we have a positive 83, positive, negative, and then a positive. So now we look at the sign changes. We start with a negative and then we change to positive here, and we have a positive and then we change to a negative here, and then we have a negative and then we change to a positive here. So we have 3 sign changes. And so we have 3 or minus a positive integer 2. We have 3 or 1 real negative zeros. So here we had 2, and so we minus 2 to get 0. We can't have a negative amount of zeros, so it just goes down to 0. And then here we had 3. 3 minus 2 is 1. 1 minus 2 is going to give us negative, which we can't have, so we know there's either 3 or 1 real negative zeros. If we had a number like 4, we would have 4 or 2 or 0. If we had a number like 5, we'd have 5 or 3 or 1, so on and so forth. So that is how Descartes' rule of signs works. We're going to move on to part B. For part B, we're going to list the possible rational zeros of f of x. So for this part, we're going to look at P and Q. P is going to be the last number here. It's going to be 21. It's going to be the number without any x attached to it. So that's what P is. And then Q is going to be the first number. It's going to be the number, the coefficient with the highest x value. So x to the fifth is going to be the highest number of x's. And so 20 is going to be our Q. And the number of possible rational zeros is given by P over Q, where P over Q is going to give us the factors of P over Q. So we're going to first look at the factors of P. So we have 21. So the factors of 21 are going to be plus, minus, because they can either be positive or negative. 1 times 21 is 21, so we have this and 21. Negative 1 times negative 21 is also going to give us positive 21, so the negative is included in there. We also have, let's see, we have 3 and 7. 3 times 7 is 21, and negative 3 times negative 7 is 21. And then there's no other factors beyond that. That gives us 21. Then we're going to look at the factors of Q. This is also going to be a plus minus kind of situation with factors. So we want to look at the factors of 20. So we're going to start with 1 again. 1 times 20 is 20. And negative 1 times negative 20 is also 20. And then we can move on to 2 and 10. 2 times 10 is 20, negative 2 times negative 10 is 20, and then nothing is there with 3, but we do have 4 and 5. 4 times 5 is 20, negative 4 times negative 5 is 20, and that is all the factors of 20. So now that we have all of that, we're going to do P over Q. I'm just going to move P over Q down here. We're going to do all possible combinations of P over Q. So we have 1 over 1, that's going to be 1. And again, this is going to be plus minus because of the plus minus up here. And then we have 1 over 20. We have 1 over 2. 1 over 10. 1 over 4. 1 over 5. So we've done everything with 1. So P over Q. Now we're going to do 21. So we have 21 over 1, which is just 21. 21 over 20. We have 21 over 2, 21 over 10, 21 over 4, 21 over 5. So we've done everything with 21. Now we're going to move on to 3. 3 over 1 is just 3. 3 over 20, 3 over 2, 3 over 10, 3 over 4, and 3 over 5 for the 3's. And then we're going to do the same thing for 7. 7 over 1 is 7. 7 over 20. 7 over 2, 7 over 10, 7 over 4, and 7 over 5. So these are all the possible rational zeros of f of x, quite a lot. So, moving on to part C. Part C asks, if you know f of x has a 0 between 1 and 2, what numbers should you check? And asked to identify possible rational zeros between 1 and 2. So, we're going to look at all the zeros, if we have a number line here, that are between numbers 1 and 2. So anything that's in between these two numbers. So what we're going to do is go back to part B and look at all of these numbers here and figure out which ones are between 1 and 2. So if we figure that out, 1 is not between 1 and 2. 1 over 20 is less than 1. 1/2 is less than 1. So if we do that for all of them, we find out that the numbers that actually are in between 1 and 2 are 21 over 20. We have 3 over 2, we have 7 over 4, and we have 7 over 5. And you can Make sure of that by plugging this into your calculator. Okay, we're going to do parts D and E in the next video. In part 2.